All right, I think it's working. Unfortunately, with this with the sun, I'm just looking at a black screen right now, pretty much. All right, I hope you can see the board. I think I have it set up. I think it has to go more that way. I might actually have to close this. Sorry.
Here's some.
Just a little bit.
When someone's fine.
I'm gonna see if I can close it just enough where the laptop is. It's not like I literally looks like a black screen. Okay, now I can sort of see it. What, Kate?
Turn up brightness.
It's because the sun is blasting the screen. That's why I can't see it. All right. So, all right. We have been talking about basically average velocity and average speed. So let's just get into it here. Number 30. So it says 30 says if you travel at 30 meters per second, units, meters and seconds are like the big ones in physics. So I know we did some miles per hour and stuff. That not going to come up very much more after this problem set. So anyway, 30 meters per second over a distance of 600 meters. So like usual, let's go. So you got a distance of 600 meters. And so the first trip you're going to travel at, you're going at 30 meters per second. So when it's a simple calculation like this, you can just go, well, I know that velocity would be how far I moved, how much time passed. And so conversely, the amount of time that passed is your how far you had to go divided by how fast you were going. So how long is this going to take? 20 seconds, right? So this would take 20 seconds. And then the trip back. Okay. It says you're going to, well, I guess technically I could have done the same distance, right? I could have gone 600 meters and 600 meters, but it doesn't really matter. I can make it a return trip as well. So if I come back going, what did it say, 60? Okay, so now we're going 60 meters per second. How long will that take? 10 seconds. And so if you want the overall average speed, go ahead, take a second and calculate that. Calculate that on your own, and then we'll check our answer in just a second. They get a new marker. This one really sucks. Anyway, the answer here. So the total distance you travel, which you went 600 plus 600 more. So you went 1,200 meters. And then the time it took was 20 seconds plus 10 seconds. And so 1,200 divided by 30 is 40. So this is one of the first times our answer came out to be really nice. But it's weird though, because you're like, well, 30 and 60, you might have thought the answer was going to be 45, right? Because the average is 45. But again, as we're seeing in these, the average speed is not. It actually is a type of mean. It's just not an arithmetic mean. Anyone knows the answer to this one? Mind explosion. Does anyone know what kind of mean? What kind of mean? Under what kind of mean is the mean of 30 and 60 40? Huh?
No.
What did he say? I didn't hear what he said.
What do you mean?
What?
Just 4
Over my head. The answer is harmonic. The harmonic. Not harmonica. Harmonic. Okay. Okay, so that leads us to the next question, 31. So the 31 is basically asking us to generalize this result. Right? So if you look back on the few problems, I think we've done 3 at this point where we've been given 2 speed values and you've been asked to calculate the average speed, and there hasn't really been an obvious relationship, right? It's like, well, how do you go from 30 to 60 and get 40? Not obvious, okay? So let's derive a formula then. That's what we do in physics. We say, how do these different quantities relate to each other? Let's try to find a general formula that will always work. So this one says, same setup, except instead of 600, we're just going to generalize and say the distance is d. And then the outbound trip, what are we calling that? What's the speed? V sub 1. And then the return trip is going to be at speed of V sub 2. Okay. Now I'll change colors here. Hopefully this is visible on the screen, but I'm going to use red to indicate the times this takes. So notice we're going to follow the exact same logical process where we find out how long does this take, we find out how long does this take, and then we write out the thing. Actually, why don't you guys just try it? Take a minute. So I gave you kind of a outline there. Write an expression for how long this will take. Write an expression for how long this will take. And then try to write a larger expression for the average speed. And if you're feeling really adventurous, try to simplify it into the nicest, prettiest form you can think of. And you can test your answer by plugging in, say, 30 and 60, and 40 should pop out. Realize the clock is still broken. Okay. All right, that might not have been enough time, but I gotta get the chargers out to you guys, so let's just go over the answer here. Who's got an expression for how long this first trip would take? Anyone? What Winslow, you had an answer?
I have like V1 or V sub 1 times T equals T.
Okay, that's true, right? So let's say that we're calling this time t. The time, so v1 times t would have to equal the distance, right? So if I want an expression for the amount of time it takes, then I would just divide both sides by v1, and I'd have this. Everyone agree with that? Okay, so this time is the distance divided by v1. Similarly, this time, the return trip would have been the distance divided by v2. And so now let's do the same thing we did before. The average speed is the total distance. What's the total distance traveled here, guys? 2d. 2 times the distance, right? We traveled distance and then distance again. Again, or we could have gone distance and then distance. We could have kept the same direction, it would have been fine. And the total time, so total distance divided by total time. Total time is d over v1 plus d over v2. Okay, everyone okay with that? Now, we're not done. Does anyone see a way to simplify that a little bit? D. Yeah, notice when you have when you have a fraction, right? Like here, let's go back to basics here. Like if you had a fraction like 12 over 18, hopefully you'd go, wait a second, I can divide both of those numbers by the same thing. I can divide them both by 6 to get 2 over 3. The same principle holds here. I can divide the top by d and divide the bottom by the same thing And what's going to happen? Does that make sense, that idea? So if I divide the top by D, what do you get?
2.
2. And the bottom, divide that whole thing, how division works. If I divide this sum by D, they both get divided. So I'd get 1 over V1 plus 1 over V2. Now that's one way to write the harmonic mean of two numbers. Basically, it's kind of a confusing formula. But you know what's amazing about this concept of harmonic mean? It actually has a really nice result. So let's take a shot at this one. Who thinks they know? Just take a guess. What's the harmonic mean of 1/3 and 1/5? If you had to guess. 1/4, right? You'd think, harmonic, okay. Seems like you're setting us up to say 1/4, right? Let's see. Let's plug these two. Let's say these are my V1 and my V2. So plug them in. So you'd go 2 over, so what's the reciprocal of this? 3. What's the reciprocal of 1/5? 2 over 8 is 1/4. Isn't that beautiful?
Yeah.
Yes, it is. Yes. So that's called. So anyway, it's called harmonic mean. It's kind of a cool idea. It's one of the only times it pops up, or as far as I know, that it pops up in nature. I'm sure it comes up other times, but this is one of the more simple times it comes up. So, by the way, we can go once. Let's say you're like, wait a second, I really hate having a fraction inside a fraction. That upsets me greatly. What could I do here to not have a fraction inside a fraction? I'll give you a hint. I'm going to be multiplying the top and the bottom by the same thing. What, Emily? Did you say the answer?
No.
Oh, sorry. I thought you were thinking. Anyone know? Anyone? How could I, in one step, make this no more fractions inside the fractions? Okay, let's give you the answer, I guess. Okay, so you're going to multiply the top by V1 times V2, and the bottom by V1 times V2. Now, what does that do? Let's do the top first, this is easier. What's 2 times V1, V2? The thing I just said, yes. And then the bottom, what's V1, V2 times 1 over V1? What's going to happen when I multiply that blue thing by that red thing? You would just get V2. And likewise, does that make sense to everyone? Because the V1s would cancel out when they multiply. Likewise, when I multiply this by this, the V2s would cancel and I get V1. So that's another way. I believe it.